Synthetic division, okay? There we go. Okay, so synthetic division is used to divide a polynomial, right, by a linear factor. Okay, so a linear factor is a factor that has a degree of 1. So like x minus k. There's a 1 in front of this x, and it's x to the first power. A linear factor. No exceptions. That's the only thing that synthetic division is good to divide by. So dividing by a quadratic, like in long division, you have to use long division. But there is a shortcut if you're dividing by a linear factor. All right? So how to, right? I showed you how to divide long division. I'm going to show you how to divide synthetic division. Okay, so the first step is going to be drop the coefficients in order, no skipping. I will show you what no skipping means. 2, drop the leading coefficient. 3, multiply by the 0 of x minus k. All right, so we're multiplying by the 0 of that factor I was dividing by. And 4, add, and then repeat. Drop, drop, multiply, add. Now, when we did long division, this is the first example that we did in our notes last time. All I did is I wrote up the problem and the answer, because that's the first one we're going to do with synthetic division, because I did it with long division. So we should be pretty convinced that that's the result. Okay, so example. 2x cubed minus 7x squared minus x plus 6. And this time I'm just writing it horizontally. I'm just writing it across. So divided by.
Can we write it the other way?
You can write it, you mean like as a fraction?
No, like up there.
You could, however, I would be able to recognize it both ways.
Oh,
okay. Because the setup is actually different. We're not going to set it up like long division. It gets set up differently. Okay. You ready? First thing you have to do, 2 rows high. It's a elongated L. 2 rows, has to be 2 rows high. Drop the coefficients in order. 2, -7, -1, and 6. Okay, that was step 1. Drop the coefficients in order. Now you can still make those columns like we did with our long division. Just if you squish your numbers too close, guys, you might accidentally call that a -16 instead of a -1 and a 6. So either put a deliberate space or divide up into columns so that you don't accidentally combine numbers. Okay, drop the coefficients. Notice that my powers, 3, 2, 1, none. They're in order and I didn't skip anything. Drop the leading coefficient, Okay, so drop, drop, multiply. Multiply by the 0 of this factor. So that is x equals 1. The 0 is x equals 1. Drop, drop, multiply. Okay. I'm going to switch colors because that's the setup. I haven't actually done anything but copy the things off of the problem. So now I'm actually going to do the division. No, the 0 is not -1. The 0 is +1. It is opposite. Okay, so look at this. X minus 1 equals 0 actually is x equals 1. Okay, good question. All right, here we go. Multiply. 1 times 2 is 2. Add straight down. Repeat. 1 times -5 add straight down. 1 times -6 add straight down. Yeah. All right, that's how synthetic division works. That's it, that's the whole process. Okay, I like it because it's at most 3 lines as opposed to long division, which takes like half a page. Okay, let's look at these coefficients. 2, -5, -6. Look at my answer. 2x squared minus 5x minus 6. Okay, so let's think. When you divide, okay, when you divide 2x cubed, right, cubed divided by x, what happens to your degree? Goes down by 1 because you're dividing by a linear power, which is a power of 1. So here's a note. When you divide by linear factor, which is exactly what synthetic division does, the degree decreases by 1 because that you subtract exponents when you divide. So I have to subtract by 1. The degree decreases by 1. So how do I actually use that knowledge? Well, if we started at cubed, you have to decrease to x squared. And then you just count down from there. X squared, x, number, remainder. And then I turn it into an answer. Equals 2x. Then you put the number with the variable. Minus 5x. And then there is no remainder, but just so that we don't forget, this is what you would write for a remainder if you actually had a number. That's exactly what we got in the first long division problem. That's the answer. Now I'm not going to box the remainder because it's a 0. Okay. That's the skill for today. We're going to practice it a few times, and then we're going to learn some applications with it. Question?
What if you had like 2 that were remainders? Like if it started at X.
Oh, okay. So the way that this works, the reason you're not allowed to skip powers is that if you don't have enough or you have too many, you did it wrong. It has to match up exactly in order for you to have filled in all the columns correctly. Okay, so here we go. We're going to do it again, and I'm going to walk you through it, and then I'll give you one to like set up yourself. Okay, so 4x cubed minus 5x plus 1 divided by x plus 2. Right, so that's my problem. Drop, drop, multiply, add. Drop, drop, multiply, add. All right, so I put my L. Cubed, single number. Notice how you're missing the square, and so we're going to get 4, right? We're missing the square. So 4, 0, minus 5, 1. 3, 2, 1, none. I just count the powers down.
Wait, so do you need to add 0?
You have to include the 0. So there's no skipping powers. You have to have the placeholder. Okay? Because the way synthetic division works is you have to have a column for everything from the first term to the last term. No skipping. Okay, so 4, 0, negative 5, 1. So all cubics should have 4 columns. If you have 6 degree, you should have 7 columns, 1 for every power and nothing on the end. Yeah.
So why did you not add a 0 for the first one?
I wasn't missing anything. 3, 2, 1, none.
Then where's the 0
In which one?
in the second one?
Why did I add a 0?
Yeah.
Because I was missing the squared power.
Oh.
I was missing the squared power. Right? No skipping power. So if you're missing it, you have to include it. 4, 3, 2, 1, none. Okay, drop, drop, multiply by x equals negative 2. So I'm going to put my negative 2 out there. And okay, what goes? Anyone brave enough to tell me? Yeah? Yep. And add. Okay, raise your hand. What goes in the next 2 spots?
16 and then 11.
Okay, last 2 spots. Yeah? Yep. And? Yes. Okay. Which x's am I going to line up here? What am I going to start with? Raise your hand. Who can tell me? Yeah, Harrison? X squared, x, number, remainder. I just start at the square. Notice if you did it right, everything's going to line up and match up perfectly. If it doesn't match up, you probably missed the 0. Because then you wouldn't have enough columns. Okay, let's just write out our answer. Equals 4x squared minus 8x, 11. I like to write my remainder with a plus and then put whatever the remainder is in the fraction, even if that's a negative. All right. You can still do long division, guys. You just don't have to if it's a linear factor. I like this because I feel like it's easier for me to find mistakes if I've made them. Yes.
Wait, I'm just a little confused. How do you know this is a linear factor?
Okay, a linear factor. It's a good question. Okay. I'll show you. Okay, linear factor looks like this. Okay? Technically, a linear factor is anything with a degree of 1 inside is a degree of 1. So something that's not linear has a degree of 2. Does that make sense? You'd have to do long division with not linear. All right, I'm going to give you two problems? Yeah, 2 problems. Okay? You have to set them up yourself. Okay? There you go. 3. A little bit of space. 4. Yes?
Where's that baby?
Construction. Okay, there you go. Those are your 2 problems. I will come around and check them for you. All right, so we get 1, 0, 0, minus 8. Missing 2 zeros that time. This is what it is. Positive 2. Okay. 2, 2, 4, 4, 8, 0. Okay. Cube it to squared. Oh, lines up perfectly. And the answer is, okay, I'm going to write this one. Right? That's another way to write division. Equals x squared plus 2x plus 4. This time there's no remainder. Anyone see the perfect cubes here? Anyone remember how to factor the perfect cubes? Square, opposite product, square. You know how I said there wasn't another way to get that formula? There is. What? Okay, it's actually not that easy when you get other numbers in there, but when there's a 1 in front, it actually is pretty easy. Okay, awesome. We're going to set up the next example, but we're probably going to wait till after lunch to do it. A little harder. Dot, dot, dot. Okay, here we go. 2x cubed minus 3x squared minus 4 divided by 2x plus 1. Yeah, you're like, well, it's linear, but it doesn't have the 1 in front of the x. And so you have to maybe force it to work with synthetic division. And so this factor right here, the 2x plus 1, you have to manipulate it to be the right format. And so I'm going to force this 2 to come out front. And this is going to be, okay, what's the 0, guys? The 0, 2x plus 1, it's minus 1/2. That's the number you're going to use in synthetic division. Because when you force this 2 out, you get 1/2. And so this is actually 2 steps. One of them is like normal synthetic division, just happens to have a fraction. And then you divide by 2. It's just 2 steps. That's it. Okay, we will continue after lunch. All right, guys, so there's going to be 2 steps to this equation. Now, I'm going to do the synthetic division first, and then I'm going to divide by 2. Okay? So I'm going to set up the synthetic division. 2. Okay, so I'm checking the powers as I do this. Okay? And then I'm going to put my minus 1/2 out here. And I'm going to bring the 2 down. So I'm set up to do my synthetic division. All right. Okay, here we go. So minus 1. So minus 4. Positive 2. Minus 1, minus 5. Okay, so I'm just going to check. Cube, so squared, x, number, remainder. Okay, so I didn't miss any columns. I have it all. And the second step is I need to divide by 2, right? You are dividing by 2 things. One of them is a linear factor. That's where the synthetic division is. One of them is the actual number. It's a scalar, which is just a number. Okay, so I'm going to divide all my coefficients by 2. Leave the remainder alone for a minute. Okay, just going to leave the remainder alone. So I'm going to divide by 2. So you get 1. Just hold on the remainder, okay? And now I'm going to line up my x's. So this is squared, x, number, remainder. There's a reason I didn't touch the remainder, okay? And I'm going to show you that. Yes?
Can you stop for 1 second? You also, the 2 divided by 2 is 10.
You mean, is it 1? Yes. Can I borrow the whiteout back? Whiteout.
That's the white out.
Okay. Thank you, because I can't divide. All right. Okay, so here's how you write the result. Equals 1x squared minus 2x plus 1. Okay, here's the remainder. Now, in order to get this remainder, you know how I didn't divide the remainder by 2, right? I just left it there for a minute. That's because I'm going to put it like this. Like you could divide it by 2, but I didn't want to write 2.5. Okay, I didn't want to write that. Now notice that this right here, I don't really want to write it like that. I would prefer to write my remainder like this. So I wanted to write my remainder over the original piece, and so this is the answer. Okay? This is the remainder. This is how I would prefer to write it. Yes?
So, I'm just a little confused. If we take the 2 out, then wouldn't it be if we like solve for x in that part? Like a whole number.
Okay, hold on. I'm going to write it again, and then I'll show it to you. Okay. So we did the first step. And the second step is I need to divide by 2. All right, so I'm just going to divide all the numbers by 2. 1, negative 2, 2, minus 5 over 2. Right? Let's just say that we divided everything by 2. How do you write your answer? We have to fill in number, remainder. Okay, so how do you write a remainder? You write the remainder. Oh, I did that again. Okay, how do you write your remainder? With the factor. So you can divide everything by 2, and then when you actually put in the x's, you put in the factor that was missing. Does that make sense? Okay, Harrison?
Why did you have to take out the 2 in the first place? Why couldn't you just take the original problem and like times 0?
Because your answer, the answer is not 2x squared minus 4x plus 2. The answer is 1x squared minus 2x. So your numbers will be off by a factor of 2. They'll be too big. Okay? All right, you ready? All right, so I'm going to show you one more. And then I'm going to let you try one. And then I will give you some work time, right, on your Delta Math. And then we'll come back and we'll do our last two conclusions. All right, so that was problem number 5. So problem 6. Okay, here we go. 6. 3x cubed plus 8x squared divided by. So if you dividing by 3x minus 5 and by this factor, if you only do synthetic division with negative 5/3, you're not actually dividing by that factor. You're dividing by this factor, which is different. Similar, okay, similar, but different. Okay, because synthetic division can be used with a linear factor, but if it's got that number in front, you've got to account for that number. Okay, so 2 steps, 1 step, 2 steps. Okay. So let's just do the first step. So minus 5/3. And then I'll wait for you, and then we'll do the 3 together. Okay, here we go. Drop. All right, guys, how do you multiply fractions? Minus 5/3 times 3, you just go straight across. All right, just a little reminder on those fractions. Okay. Add. Okay, that one I can do. Minus 5. Okay, so I've got minus 5/3 times 15. You can multiply or divide. All right, multiply or divide. So I'm actually going to do 15 divided by 3. So I get negative 25. You guys get the 0 remainder also? All right, 0 remainder. Okay, here we go. Second step, right? There's the first step. Here's the second step. Divide by 3. Right? You would have to divide everything by 3. Now, just don't reduce the remainder. That's what I'm trying to say. Just leave the remainder. So we get 1, 1, 5, 0 over 3. Right? When you write in that remainder, that's what you write in. That's what the remainder goes over. Both the 3 and this.
Can't you just write it over the original?
Yes. Okay. So how do I write this in? We go x number remainder over the original, because the original accounts for both the things I had to divide by. So we get 1x squared. And actually there is no remainder. Okay, I'll write it, but I'm not gonna circle it because that's what your remainder would look like, whatever the number is over the original factor. Okay, you guys try this one. Divided by 3x plus 2. All right, 2 steps. You gotta turn this into, right, 2 things you have to divide by. All right, figure out what you get. Okay, so we go 3, 17. Minus 2/3 and 3. All right, keep going. Yeah, I'm coming. No, I would rather you write it over this. Yeah. Okay, so if I have to multiply these 2 things together, I would probably do the divide by 3 and then the multiply by 2. And 12, 9, right guys, it's arithmetic. Switch it around, whatever you gotta do. Okay, so now I have to divide by 3, right? I have to divide by 3, okay? And then, right, I have to divide by 3, and I have to write in the x's. Yeah. Negative 3? Yes. Thank you. Negative 9. Okay. So we need x squared, x, number, and the remainder. The remainder is the thing that gets this part. Okay, so here we go. Divide by 3. So we get 1x squared. 5x minus 6 plus the remainder. Right? See how the 3 is staying there? I'm not reducing it. Now, I don't actually want to write it like that. I would prefer that the answer is written like this. Okay, so what do you need to notice? Okay, notice that this original remainder is that number. Okay, why does nothing happen to the remainder? Because right here, that is already including the divide by 3. It's already there. Right? The remainder is this number. Okay? Because the divide by 3 is incorporated there. That's why I don't need to do anything to it. Because I want to be able to write my final result with that original factor here. Okay. We'll pause there for a little bit. Okay, we're going to look at the remainder theorem.
How much space is this?
Less than what we've already done.
Okay.
Half as much as what we've already done. Okay? Remainder theorem. The remainder theorem says if, a polynomial is divided by this linear factor, okay, that's what we're dealing with, then, P of K equals R. And I know that you're like, there's a lot of letters there. I'm not sure I understand what you just said, okay? So I'm going to, underneath of this, I'm going to set up what my synthetic division would look like, okay? There's the general setup. K, we know what number goes out there, okay? And we know that that last number there is the remainder. So over here, it's a coordinate point. Those two numbers have a special place on the graph. It's actually an XY coordinate. The remainder is the Y coordinate. Okay, so there's two ways to find the remainder. One of them is with synthetic division. One of them is by plugging in the X coordinate. Okay, so that's what the remainder theorem says. This K and this R are actually an XY point. Okay? So I'm going to ask you a question, and we'll do it both ways, and then we'll put a box around the answer. Okay? Find f of 1. So I'm asking for a y coordinate. See that? F of 1 is the y coordinate. Here's my f of x. Now, we have two ways to do it. So we are going to do both ways so that you can see the connection between the two.
Is that a 5 or a 3 for the x coordinate?
5. All right, so I'm going to set up what it looks like. Okay, so over here, I'm going to do f of x divided by that factor. See that? X minus 1, because it's got to be the opposite. Over here, I'm going to actually plug in x equals 1. So those are the two things I'm going to do. Okay, here's my x coordinate, right? Corresponding to that factor. Notice they're opposites. Okay. Okay. 5, 4, 3, 2, 1, none. All right, so I got quite a bit of missing zeros there. It's okay. And I got a 1 out here. See that? This number is what's matching. Okay. That's the spot I'm looking for. I'm looking for the remainder. Okay. The remainder is -5. Right? That's the question, right? Find f of 1. I get to pick whatever work I want to find f of 1. I'm showing you two ways. One way is using synthetic division because the remainder is actually the y-coordinate. And one way is the way that you're used to doing it. Just plug in the number. Okay? 2, 1 to the 5th minus 4, 1 squared minus 3. I like to combine two numbers at a time. What? The answer is -5. It's supposed to be the same thing. It doesn't matter which work you do to get there. So what's the answer? The answer is -5. What is the y-coordinate? It's the remainder, or I actually plug it in.
How did you get f of 1?
That's the question. Find f of 1.
What if my question is just if f of x is an equation, then what is the remainder when f of x is divided by x minus 1?
Hold on. Next question. And I'm going to rephrase it. Okay. What is, yes, the remainder when f of x is divided by x plus 2? Is that a good question?
Yeah.
Okay. So first I actually have to tell you what f of x is. So let's say that f of x is 2x cubed plus x minus 1. I want the remainder. So automatically you're like, oh, I should do synthetic division because remainder makes me think division. Y-coordinate makes me think plug in. Right? Do it both ways. So over here, I'm going to do the division. Two, 3, 2, 1, none. Put my number out here. Right? Synthetic division is not the part we're focusing on now. Now it's interpreting the different pieces of it. Yeah, okay. So the remainder is -19. Seems simple enough to set up division. Okay, but what if f of x when x is -2? Notice, right? -2, remainder. -2, the y-coordinate. Those numbers should be the same. It just gives you two options. The hard part is going, it's asking me for a remainder, but I'm going to find the y-coordinate. It's doing like the alternate choice. Right? The words in the problem lead you one direction. Don't forget about the other choice. Okay, so I guess I'm just going to plug it in. 2 times -2 cubed. Okay, negative times negative times negative is negative. What? That's the whole point. It's supposed to be the same. So whether I'm asking you for the remainder or a y-coordinate, you always have two choices. The remainder is negative 19. Now I boxed these in the separate columns because I boxed it with the work that the directions was leading me towards. It doesn't matter how you get there though. Okay, so here's your cookie question. Don't share your answer because I need to know. I only have 6 cookies to give away. I would choose the y-coordinate way because I would have to plug in -1. Not +1, -1. So an odd exponent, woo, -4. Less work, not 16 zeros. 1, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Guys, there's way too many zeros to do it the synthetic division way. All right, nice work. Okay, get your delta math